Thank you very much. I do see my slide presentation, and thank you for controlling this, Mankwe. And thank you, Yancy, for inviting me to speak today. I've been asked to speak on developments in addressing the energy crisis in South Africa, and I'm going to take that to mean the electricity crisis in South Africa and focus really my comments on that. So if I may ask you to move to the next slide, please, Mankwe. Okay, so, I think this slide tells you and shows you the level of energy that has not been delivered to the productive economy when needed for the years from 2007 up to 2023. And you can see, from 2018, this very exponential increase in unserved energy, which indicates really the cost to the economy, which has been dramatically rising. And in fact, in the year 2023, last year, we overtook 2022 as the most intensive load shedding year to date. More than double the load shedding of the previous year in terms of unserved energy. And stage 6 load shedding increased by more than 6 times in 2023 compared to 2022. Now, I don't have to tell you about this. You feel it yourselves every day, or you felt it every day last year. So this presentation is going to look at this load shedding, past, present, and perhaps a future outlook going forward. And this is looking at the past, the backward-looking view from 2023 backwards to get an idea of what has been happening. It's very important to understand where we're coming from, before we can understand where we are today and where we are going in the future. Now, I know the audience is of a scientific nature and technology nature, so there's going to be a lot of graphs in my presentation. I believe in the data. Let's look at the data, not at the public relations, to try and understand where things are, where they've been, where they are at the moment, and where they're going. So this slide really talks to your own lived experience in terms of load shedding, looking backwards. If we can move to the next slide. Okay, this is another way of looking at the performance of the Eskom generation fleet. It is the so-called energy availability factor. It looks at the percentage of Eskom's fleet that is in commercial service that is available for duty. In other words, the availability factor as a percentage of the commercial fleet which is 100%. And when they say that the availability is 60%, it means that 60% of the commercially available fleet was ready for service, and the other 40% was not available for service for whatever reason. And you can see this plotted, this data plotted, since 2016, the beginning of 2016 to the end of 2023. So again, this is a backward-looking graph, and it shows this availability factor with a general downward trend every year. You'll see during the year, there's this parabolic shape where the availability increases in the middle of the year and decreases towards the end of the year. That's because Eskom do a lot of maintenance during the summer months so that the units are more available in the winter months to meet demand, and then drop off again in the summer months as Eskom do more maintenance on their fleet. And therefore, because they're doing more maintenance outages, there's less generation capacity available to meet demand, and demand is lower anyway in summer. So you get this parabolic shape every year, but if you look at it over the last 5-6 years, there is this general downward trend. And again, this is a backward-looking view, and it just gives you a clear understanding of the direction where things have been going in the past. So if we can move to the next slide. Okay, so as a result of all of this very bad trend and massively increasing load shedding that I've shown you in the previous slide, the president developed a plan to end load shedding. And this was published after a long gestation period, a lot of consultation. And this is a cut and paste out of the plan. And it really covers 5 main points. And the first one is to try and fix Eskom and improve this availability factor, which was declining year on year for many years. And then the other aspects, relate to, doing something to make sure that the private sector come on board as part of the solution, whether these are large generation projects, renewable energy, and battery energy storage, or gas to power projects, essentially built and financed and operated by the private sector, but procured through a public procurement process, the so-called risk mitigation IPP program, the renewable energy IPP program, and the latest battery energy storage IPP program. So these are procurement processes facilitated by the IPP office, but the projects are independent power producers that finance, they design, they finance it, they build it, they operate it, and they own it. And generate power into the grid, and it's to accelerate this and enable this. And there was, things done to do this, and of course, at the same time, to unleash the rooftop solar PV market, which is really residential and commercial sector, and the agricultural sector, from installing rooftop and, in fact, ground-mounted solar PV and battery energy storage. And then the last point is to fundamentally transform the energy sector, which is not a short-term project. It's not going to deliver immediate results, but it is necessary in the long term to attend to the underlying structural problems that got us to where we are. Again, if I can ask you to move to the next slide, please. So that was the president's plan to end load shedding. And a lot of work has gone into this with the appointment of the new Minister of Electricity, who, in my opinion, has brought a new energy to the energy sector. He really, is at the coalface, so to speak, in dealing with the problem. He is the face of government's interventions, and not only government's interventions, but the interventions together with business and the private sector to get to grips with this plan that the president put forward. And they established a thing called NECOM, the National Energy Crisis Committee, which comprises. The head of this is the Minister of Electricity, and beneath him are a number of government departments who have then set up a number of work streams comprising experts from the private and public sector to address the various aspects of the president's plan. And so we've got to ask ourselves now, we've looked at the past, where are things today? And of course, there's a lot of hype, and there's a lot of PR, and there's a lot of messaging being put out. And I think it's up to us now to try and distinguish the hype from the reality, and what is really going on, because we have experienced a significant reduction in the intensity and frequency of load shedding this year. And one has to ask the question, how and why is this happening? Who do we credit, for this success? And I want to say that it is it's not just one party that is success. It's not just Eskom. It's not just the private sector. It's not just the minister. It's a whole lot of issues coming together, and thankfully, they are coming together because we can feel the difference. Of course, there are many suggestions that this is an election ploy. This is just something that we're going to see a big improvement before the election. And after that, things will go back to the bad old days. I want to say that I don't believe in these conspiracies for 1 minute. And really, neither should scientists and technologists and engineers. We should look at the data and understand the data and understand what is really going on. I don't believe in conspiracy theories. In an organization as big as Eskom, it would be impossible to conduct a political conspiracy to hoodwink the public before an election. There are just too many people. It would be too difficult to hide. There would be too many whistleblowers running to the media. So I think we got to look at the facts rather than the spin and the rumors that go around, usually by people that know very little about the electricity sector, and sit around talking about it, amongst themselves. So the first thing to look at is what is happening this year to unplanned breakdowns compared to last year. And that's what this graph shows. The so-called unplanned capacity loss factor is an indicator of what percentage of the fleet is broken down for unplanned, is out of service because of unplanned breakdowns. And if you can see that last year it was kind of hovering around about, that's the blue line, about 35% of the fleet. And this year, if you look at the orange line, it's hovering around about 30%. That's a 5% reduction in unplanned breakdown. That is very significant if you turn that into kilowatts and megawatts. There is no question about it that the level of unplanned breakdowns has noticeably decreased from last year. And that's what we're trying to see here, is what is happening now. We looked at the past 5 years, and now we're looking at what's happening now. And this year, you can see in the orange line that unplanned breakdowns are consistently lower. And that's a very good sign. It means that the people at Eskom are indeed getting to grips with this problem, and there's a consistent reduction in unplanned breakdowns. But now, can we go to the next slide? And this next slide looks at what is called the planned capacity loss factor. This is planned maintenance outages. Now, have a look at the blue line, which is last year. And again, to show you this sort of parabolic trend with a very noticeable anomaly between week 10 and about week 17. But if you can see, the planned outages decrease in winter, and they start to increase again in summer at the end of the year. Remember, at the horizontal axis in the bottom is the week number. So on the far left is the summer months, on the far right is the summer months, in the middle is the winter months. So you can see that there is this parabolic trend following the normal pattern, but there was a very noticeable exception between about week 10 and week 17, where there was a massive increase in planned maintenance during this period last year. Well, this year, as you can see from the beginning of this year till to date in the orange curve, it is following the normal trend of reducing planned outages as we move to winter. So there's nothing unusual about the trend, but what is unusual is that the amount of planned maintenance was the beginning of this year, and for the first up to about week 12, is consistently much higher than it was last year. In other words, they're doing more planned maintenance. Why are they doing it? Well, there's more money that has been set aside for this purpose, and they've got the space to do it. Because remember, in the previous graph, we showed that unplanned outages were consistently lower this year. That means Eskom had more headroom to do this planned maintenance, because you do need headroom to do this maintenance properly. Otherwise, you're going to take units out for planned maintenance, and you're going to result in massive load shedding. Now, these two are actually counteracting each other. In other words, on the one hand, we're having less unplanned breakdowns, but on the other hand, we're doing more maintenance. And the two counteract each other. And so if you move to the next slide, where you look at the amount of generation capacity that is available to meet demand, you can see, up to about up to about week number 12, week number 13, the energy availability factor was very, very similar to what it was last year. And that's because the decrease in unplanned breakdowns was offset by the increase in planned outages. So overall, the net available generation capacity was about the same. But you can see in the last few weeks, from week 12 until week 16, there was a very big drop last year in the energy availability factor. And that was because of that anomaly that I pointed out in the previous slide, where they did massive amount of unplanned outages. And that caused less availability. I haven't got to the bottom of that anomaly, but the bottom line is that right now we are moving above the situation last year. So in the last few weeks, the availability has been higher than last year, and we can feel it because of the lower load shedding. So, but this is not the full story. So this I'm telling you this because I think we are beginning to see the noticeable impact of Eskom's additional efforts. And we're seeing the reduced unplanned outages. We're seeing the ability to do more maintenance. And in the last few weeks, you can see how that's been impacting on the energy availability factor, which has actually improved very significantly compared to last year. But I must say, still at unacceptably low levels. When I showed you that graph of the unplanned outages hovering around about 30%, it is really out of line that South Africa should have 30% of its fleet out of service. It should be more, as a result of unplanned breakdown. It should be more like 10% out of service due to unplanned breakdown. So even though the energy availability factor has significantly improved, it still has not even reached 60% yet. The minister quite often talks about that it's reached 60%. It hasn't reached 60%. It's starting to approach it, but we're not there yet, and we're behind in the target, significantly behind in the target. And so there's still a lot of work to be done, even though things do look promising right now. Next slide, please. So I mentioned that this improved performance of Eskom is not the full picture. It's part of the picture as to why we're experiencing less load shedding. And I want to try and explain to you, what else is happening besides Eskom fixing its broken down plant. And this graph is not my data, or this table. It's not this comes from Eskom. It's Eskom's data. And if you look at the very last column on the right-hand side, it shows month by month, since July 22 at the bottom up to March 24 at the top, how much rooftop solar PV is on the grid generating. And you can see how it's dramatically increased. And at the moment, we're sitting at about 5,400 megawatts of rooftop solar PV and battery energy storage in the residential and commercial and agricultural sector. It is really very significant. It's been increasing rapidly, and it is contributing to helping reduce the burden on Eskom's fleet and thereby reduce load shedding. It is meaning that Eskom is not under as much strain as it was, because this generation is reducing the burden of the Eskom portion. So let's move to the next slide. Another table straight out of Eskom's weekly system status report. The important thing to look at is the bottom two lines. The one in red, where it says total including other renewable energy, that is all the non-rooftop renewable energy in South Africa. That is from the public procurement processes, the risk mitigation IPP program, the renewable energy IPP program, the battery energy storage program, totaling 6,400 megawatts. And look there, the estimated rooftop solar PV is very dramatic. Okay, and this covers commercial. This covers commercial, residential, commercial, agricultural sector mainly. Add the two together, you've got 11,000 or nearly 12,000 megawatts of renewable energy. This is very, very significant, and it's making a big difference, even though renewable energy, we know, is not a constant output. We know that that it doesn't run at 100% capacity factor. But when you add 12,000 megawatts of peak capacity to the grid, it's going to make a significant difference, not only during the daytime but also at night, because part of that 6,430 is wind. And wind the wind blows more in the night than in the day. So this is all very, very helpful and explains also that this is what is contributing. This uptake of renewable energy is making a significant impact by reducing the burden on the Eskom fleets. Can we go to the next slide, please? Okay, but that's again not the whole picture, because we have to look at what's happening in electricity demand in South Africa, uh, and um, and this is quite a complex, story, because first of all, to say that the economy, well, let's just look at the data before we start thinking about why it looks like it looks. But can you see that in the last, since 2012, since 2011? In fact, the amount of energy produced by Eskom is getting less and less every year. The trend, downward trend. And we're now at in the end of 2023, we were at a 20-year low. And so we're going to look at the reasons for that. But again, whatever the reasons are, the burden on Eskom is being removed. And this doesn't mean to say that the country is using so much less electricity. It just means that Eskom's share of the electricity produced in South Africa is declining. And that is helping to reduce the burden. And we're going to look at, there are a number of reasons for this as to why is it declining. First of all, the economy in South Africa is very flat. Because of the weak economy, GDP growth is pretty flat, and therefore electricity demand overall is pretty flat. At the same time, the energy intensity of the South African industry has been reducing. So in other words, the amount of electricity we use to produce a unit of gross domestic product has been declining as we move away from energy intensive industry towards more services and light manufacturing industry. The days of the heavy energy intensive industries are they're under pressure. And part of the pressure is the price of electricity. The price of electricity has gone up dramatically year on year, significantly above the inflation rate. That's causing business to tighten their belts and use electricity sparingly and much more efficiently, not just at an industrial level, but across the whole economy, residential, commercial, industrial, mining, agricultural. We're all under pressure, and it's all causing people to use electricity more carefully, more efficiently, and to reduce unnecessary expenditure. And in fact, we've also, the South African economy has been held back by energy supply. The very fact that Eskom have not been able last year to deliver the electricity needed by the economy has contributed to these declining graphs that you're seeing here. They just didn't have the capacity available. So if we can move to the next slide. Okay, so now let's just quickly run through this. So why has load shedding stopped for now? Firstly, as I indicated, I think the results of the president's plan to end load shedding and the work done by the Minister of Electricity and Eskom are beginning to show. But that's not the whole picture. But congratulations to them for that. And let's give credit where it's due. The weak economy I've talked about, and the resulting generally flat overall demand for electricity. The rapidly rising price of Eskom electricity and municipal electricity of 2 to 3 times the inflation rate sustained for many years is dampening demand for Eskom electricity. And that doesn't mean to say all electricity, but Eskom electricity has been getting much more expensive year on year. Load shedding and the low reliability of Eskom and municipal electricity, particularly over the last 4 years, has been negatively impacting the electricity supply and demand for electricity. Finally, second last, electricity customers have been responding to these rising prices, to the poor security of supply, by moving to self-generation and alternative energy sources. Including at the residential level, to rooftop solar PV, battery energy storage. People are using gas for cooking. They're using solar hot water geysers. They're looking at energy efficient lighting and a general reduction in demand. And it goes way, way beyond the residential sector, right across the economy. All customers are facing the same problems and all are responding to it in one way or another at different levels. And then lastly, of course, this pipeline of big renewable energy projects and battery energy projects, is coming to the grid. It's been slow in coming to the grid because these projects take a couple of years to develop, to become projects that are now going to get financial closure. And then there's a certain period for the actual construction. And so it can take 2 to 4 years for these kind of projects from really the beginning concept to the time they come to the point is there is a big pipeline, and the pipeline is now starting to deliver, and we're going to see an acceleration of these big renewable energy battery storage projects, both from the public sector and from the private sector, through wheeling of power, trading of electricity, is all going to contribute towards a lot of new generation coming on stream. Next slide, please. And that, of course, is the reason, all of these reasons that I've listed here are the reasons why we're experiencing less load shedding. Not just one reason, many reasons. This is now, and I'm not going to dwell much on this, but if you want to look at the future outlook for new capacity, I've talked about, what's coming on stream, the pipeline, but one's got to look at all the different sectors of the economy. This is a 3-year view that I did for a client for up to the year 2026, and it broke it down, to the Eskom. What's going to come on stream from Eskom? Not much, to be honest. Yes, 2 units, 800 megawatts at Medupi, 800 megawatts at Kusile. That's what's going to come on stream from Eskom. But have a look at what's coming on from other sources. Public procurements, the renewable energy IPP program, the battery energy storage program, the risk mitigation program, 4,700 megawatts in 2026 alone. That's in 1 year. Imports of electricity from our neighbors, municipal electricity generation, private power purchase agreements, domestic and residential and commercial sector. And can you see that in 2023, 3,000 megawatts is planned to come on. 2024, an additional 6,400. 2025, an additional 8,300 megawatts, and 2026, an additional 13,000 megawatts. These are massive new generation capacity being brought to the grid across Eskom, public, imports, municipalities, private PPAs, and residential and commercial. Looking ahead, I personally feel that the intensity of load shedding, whilst it's not over, the intensity and the frequency will continue to decline. It'll become more intermittent load shedding. But I am pretty confident that all these things, including the work done by the Minister of Electricity, by NECOM, by Eskom, by the private sector, and finally also the restructuring of Eskom, is all happening as we speak. And this augurs well for the future. Next slide, please. So this is my last slide, and that's to say, we need to move from a phase where we've been doing crisis management. That's where we are right now, dealing with the immediate issue, to dealing with the longer-term issues. And that means proper planning. From non-negotiable policy positions of government, for example, decarbonization, meeting net carbon zero by 2050. These are long-term, which should be non-negotiable policy principles that all our planning should be aligned with these principles. We need, proper energy and electricity policies by government. So once you've defined your non-negotiable principles, we then need policies that are aligned to these principles. And then we need plans. We need an integrated energy plan. Can you believe it that South Africa, since 2008, we have never published an integrated energy plan in South Africa? But fortunately now, it was gazetted late last year, that government has to produce an integrated energy plan in terms of the law by the 31st of March, 2025, our first integrated energy plan. I mean, is it any wonder why we have an energy and electricity crisis when we don't have an integrated energy plan for South Africa? Then, of course, we need sector plans. And one of the sector plans is the Integrated Resource Plan for Electricity, the IRP. Now, you know that the draft IRP 2023 was published for public comment, but it still hasn't been published yet, and the last one was in 2019. These things should be done every year, if not at most every second year, every alternate year. So we do have sector plans. Some of them we don't have. The electricity we do have, but it's out of date. We need up-to-date plans, and then we need regulations that are aligned with these plans. So what I'm really saying is that we need to move from crisis management to a proper planned process where we have policy principles, we have policies, we have an integrated energy plan, we have sector resource plans, integrated resource plans, and we have all the necessary regulations that are, and these need to be all aligned with each other, not one hand not knowing what the other hand is doing, not one minister saying one thing and another minister saying another thing. We need to be working together as Team South Africa, and that is what is going to solve our electricity problem in the medium to longer term. Thank you, ladies and gentlemen, for your attention.
Thank you very much, Chris. Right, we can take some questions from Nanda Govender. Chris, your thoughts on the current IRP and Eskom's decommissioning plans, and whether RSA are making the right choices to enable energy security in 10 years' time?
Yes. Look, my view on the integrated resource plan for electricity has been well articulated in the public domain. I think, and I need to be a little bit harsh here, I think it's a poor piece of work. I prepared the comments to this draft IRP for OUTA, and OUTA's comments are in the public domain, and you can read what I wrote, and you can see exactly what I said. And it's not about just being constructive. One has to be constructive, but one has to speak truth. And in my view, there are deep flaws in the current draft IRP, which I have articulated in this document. It's in, if you go to the OUTA website or you do a Google search on it, you will find my comments, formal comments to government on behalf of OUTA in there. I also did comments on behalf of other stakeholders. As a consultant, that's what I do, and they contract me to write comments. Not that I do it in a way that is not supervised. They don't just take my comments and they review them, make sure they align with their own view, etc. But I don't want to. I could spend an hour talking to you about what is wrong with the IRP. You can read about it in my comments that I've done on behalf of OUTA.
Okay.
What was the other question? Sorry, there was another question to that.
Whether RSA is making the right choices to enable energy security in 10 years' time.
I think the IRP is making the wrong choices. I think there is a misalignment within government between the DMRE and a number of organizations in the presidency, including the Minister of Electricity, the Presidential Climate Commission, and Operation Vulindlela, and the various initiatives in the presidency itself, I think, are misaligned with some of the initiatives of the DMRE. They're not on the same planet, if you ask me, and that's a problem. We need to, as I mentioned in my presentation, we need to have consistent overall principles, policies, and laws and plans in place, and we shouldn't have this dissonance between different government departments. So I don't think the IRP presents the right choices, but I think other people in government, particularly in the presidency, know very, very well what the right choices are.
Yeah, right. Thank you. Will you take another question?
Certainly.
Rajeshni Mahabir from Asaf asks, being respectful of electricity consumption and using it efficiently is not installed in South Africans. How can we instill the importance of using electricity efficiently and responsibly to minimize waste and environmental impact in South Africans?
Yeah, I'd like to make two comments on this. One of the points I made in the draft IRP 2023, that not a single word in that draft IRP talked to energy efficiency and demand side management. It's a very noticeable omission of the contribution that energy efficiency and demand side management can make at very low cost. The cost of using electricity efficiently is the least cost option, to reducing load shedding in South Africa. And there was nothing in the IRP mentioned about energy efficiency and demand management. Is one of the things that I pointed out. So I agree with that questioner. That not enough attention is given to this. The other thing I want to mention, I talked about it in the media recently. There's a massive new project that has just been commissioned. It's called the SkyTech project. It's a hybrid project of battery energy storage and solar PV. It's the biggest renewable energy project in South Africa by far. Just the solar PV portion of this is 500 megawatts. This is massive in the South African context and, in fact, in the global context. But do you know that of that plant is curtailing and wasting 30% of the energy produced? That should, at a time of energy shortages, should be going into the grid. It is being curtailed because of contractual reasons, nothing to do with technical reasons, or it's mindless. And it was due to very poor specification and contracting arrangements organized by the IPP office, and it's resulting in 30% of the energy from that plant going to waste. When you talk about energy efficiency, that is serious stuff. This is, and you may remember just the other day, the Minister of Electricity said that he knows this. It's been brought to his attention by SkyTech about the wastage of energy taking place, and that he's attending to this matter as a matter of urgency. And I really commend him on being bold enough to acknowledge that and to do something about it.
Okay, yes, at least that. Oh my goodness. Okay, there's a lot of work still to be done.
Yes, but there's good progress being made.
That's fantastic. I don't see any other questions. Does anyone have a hand up? Doesn't look like it. Any other questions? Okay, I think that is it. Chris, thank you very much indeed for your presentation. And we've got, I think, quite a good idea now of not just the dire situation that we're in, but the glimmer of light at the end of the tunnel, which is not yet extinguished, and some idea of the kind of challenges that we have going forward as a country. Thank you very much indeed for your presentation.